Hi, my name is James Blair, and I'm here to talk about Zuul, specifically our new methods for managing test resources in Zuul. Zuul is a project gating system that was originally developed for the OpenStack project. Now it's used by many other open source projects and companies. I'm the original author of Zuul, I'm one of its current maintainers, and the current project lead. I started a company called Acme Gating to help companies use and scale Zuul effectively. Before we dive into the new features of Zuul, here's a quick overview of Zuul itself, and some of these ideas are going to come back and be relevant later. Zuul is Git-driven, it provides centralized or decentralized control, it supports project gating, speculative execution, cross-project collaboration, and it's scalable. Zuul supports a Git-oriented workflow for both development and operations. Zuul allows a lot of control over whether the configuration is managed centrally or end-user developers have the flexibility to manage the system on their own. Instead of being limited to testing changes after they merge, or testing changes as the developer wrote them, Zuul tests changes as they are going to merge. In other words, Zuul constructs a proposed future state of not only the repository under test, but all the other involved repositories, and it validates that proposed future state. And a property of a project gating system is that every change proposed for a repository is tested before it merges. To accomplish this work, Zuul uses ephemeral test nodes. Those nodes could be virtual machines in clouds like OpenStack, AWS, Google, Azure, or IBM, or they could be pods in Kubernetes or OpenShift, or simply static nodes that are attached to real hardware. Up to this point, Zuul has used a companion program called Nodepool to manage these test resources. It's composed of two processes: the launcher, which launches virtual machines in clouds or pods in Kubernetes, and the builder, which creates VM images. The rest of this talk is about the end of Nodepool. The Nodepool builder used a program called Disk Image Builder to create its images. But now Zuul is removing that limitation, and you can use anything, whether it's Disk Image Builder, Packer, or simply snapshotting a node. In the earliest days of the OpenStack project, our builder for CI images was originally a Jenkins job that built and uploaded an image to a cloud. But clouds are unreliable, so we needed a daemon to handle that uploading and the retries involved. But a drawback of this approach is the poor accessibility and visibility into the builds that happen on this daemon. So instead, we're moving the build process into Zuul jobs. That means it's easy for any user to see the build history of any particular image build. But we still have that problem of cloud reliability. So there's a new Zuul daemon that handles the uploads, but not the builds. Because the Nodepool builder system used a long-lived daemon for image builds, it was able to take advantage of caching because the caches could be kept on the server running the daemon. If we're going to build images in ephemeral Zuul jobs, we need to think about how we can retain some of that caching. The approach that we're going with is to use cloud images to bootstrap the building of the initial Zuul image. Subsequent Zuul image builds can then run on a node that is launched from one of the previous Zuul image builds, which means that everything cached in the previous build is available for the next build. Zuul jobs are self-testing, so that if you propose a change to a Zuul job, when that change is tested, the change to the job is reflected in that test run. Changes to build jobs are self-testing as well because they simply run the build. Once a Zuul job builds an image, the build is stored in a temporary space. For example, a cloud object storage system. After that, the job ends and control is handed over to the zuul-launcher daemon. This process downloads the image and then uploads it to whichever clouds need it. Some clouds can also do direct import of images, and so we can skip the download and upload step. Optionally, Zuul can be configured to validate an image after the upload. This would run a new Zuul job with the newly uploaded image just to validate it. In other words, the image is not put into production use yet until it passes this validation step. The zuul-launcher supports user-serviceable cloud configuration. We want as much of the Zuul configuration as possible to be inside of Git repositories and accessible for developers. This means that the image and test node configuration are both kept in repo Zuul config. Developers can, if you permit this, directly add new images or test node configuration in their own repositories. This allows for a mix of centralized or distributed test resource management. The new zuul-launcher adds a number of concepts that a Zuul operator should be familiar with. We'll talk about each of these in turn. An image describes, well, an image. It might be a virtual machine image or a container image or merely information about the operating system running on a static node. There's a new top-level configuration object in Zuul configuration called an image, and it has one of two types. It's either a Zuul image, that's an image that Zuul expects to build and manage and upload, or a cloud image, in which case it's just an image that is already provided on the cloud through some external means. If you're going to use a Zuul image, then you're going to need a job to build it. An image build job is just a regular job in Zuul with one extra feature added. It's a job that has an image build name set. When you set the image build name, you tell Zuul that this is the job that builds this image. A flavor holds information about the physical characteristics of a node that zuul-launcher is going to launch. It includes things like the size of a virtual machine, the amount of RAM, CPUs, disk configuration, etc. A label is a continuation of a concept that we already use in Zuul, where a Zuul job will request a node from Nodepool by using a label. Zuul jobs are going to continue to request labels, but they're going to be requested from zuul-launcher instead of Nodepool. Zuul-launcher needs to know what these labels are, so before you can use a label in a job, you need to define it. A label defines a unique combination of image and flavor. So when a job requests a label, it's really requesting a node of a certain flavor with a certain image. A section is attached to a connection, which is defined in the main Zuul configuration file by the administrator. For example, on the screen here, we have a section connected to a cloud called RacksFlex. On that cloud, we've made the 4 GB flavor available, and we've made the Debian Bullseye image available. Once we've defined a section, we can then define a provider. A provider inherits all of its general information from a section, but then additionally makes labels available. The provider is ultimately what will end up providing nodes to the job. Compared to Nodepool, the zuul-launcher also has some significant performance improvements. Zuul-launchers are cooperative so that you can run as many as you need to scale out your Zuul system. They use rendezvous hashing to decrease contention when they're processing requests. And multiple providers can service a single node set request. That means that a single job can request nodes from Kubernetes and a virtual machine cloud. If you're running Nodepool today, then you'll be happy to know that Nodepool and the zuul-launcher can cohabitate. That means that you can start running a zuul-launcher while you continue to run your old Nodepool system. You can then switch over to the new system one label at a time. If you'd like to learn more about Zuul, visit zuul-ci.org. And if you'd like to learn more about Acme Gating, visit acmegating.com.